Question 2, got an esterification reaction between ethanoic acid and ethanol to make ethyl ethanoate, an ester which has got a COO linkage in there and water. Write an equation, so CH3COOH, CH3CH2OH makes ethyl ethanoate, which is going to be CH3COO, CH2CH3 and water. Draw the skeletal formula of ethyl ethanoate. Well, before you draw a skeletal formula, I would always draw this out. So I'd always draw it out and see what it looks like. CH3COO, CH2CH3. I would always draw that. And then you can draw out the skeletal formula. So you put the C's as dots or just corners on a zigzag line. Remember the carbon backbone is in a zigzag line. You leave the hydrogens off and you draw the O's. So it'll look a little bit like this. So you've got CH3, you can put that up or down, doesn't really matter. The CO next, that can go up or down based on where you've put the methyl group. So this is the methyl group up and the CO down. You could have it the other way around if you wanted to. And then come along is an O and then a CH2CH3. So we just show that by a kink in the chain. So there's the CH2 and there's the CH3 at the end. The student used a small amount of concentrated sulfuric acid to act as a catalyst. How does the catalyst work? Well, it provides an alternative route or mechanism for a reaction and therefore, by doing so, lowers the activation energy. Catalyst provides an alternative route for a reaction or mechanism. Same thing, both are allowed. This lowers the activation energy. A student mixed 0.435 moles of ethanol and 0.435 moles of ethanoic acid and then used 5.00 times 10 to the minus 4 sulfuric acid in the mixture as well. The mixture is left for a week to reach equilibrium. The equilibrium reaction was stopped by adding the mixture to water. The Kc, the equilibrium constant, was 4.07. Calculate the volume of 0.4 mole dm to the minus 3 sodium hydroxide required to react completely. This is a tricky question. Very, very tricky indeed. So let's have a look at the solution. Let's see if we can talk it through. So what you've got is the mole. I've written out the equation, and then I always do a table. I always do moles at the start, and then moles at the end, and then left over. So I've got moles at the start, 0.435 moles of ethanol, 0.435, same amount of ethanoic acid, and I haven't got any ethyl ethanoate, and I haven't got any water produced. Now, it doesn't tell me how much ethyl ethanoate and water I make, so I'm going to call that X. Now, 1 mole of ethanol reacts with 1 mole of ethanoic acid to make 1 mole of ethyl ethanoate and 1 mole of water. So, whatever amounts I make, X, that's the amount that's used up. So if I had 0.435 of this at the start, I've used up X amount, X number of moles of this to make X number of moles of ethyl ethanoate and X number of moles of water. And similarly here, I've used up X amount of those. Now if I've got my equilibrium constant, which equals 4.07, and it's the concentrations of the product divided by the concentrations of the reactants that looks like that, then the concentrations of each of these are X, so that's X squared, divided by 0.0435, take away X, and it's the same in both cases. Then if I square root everything, I'm allowed to do that. If I square root everything, square root of 4.07 equals the square root of X squared, which is X, the square root of 0.435 take away X squared, the square root of that again is 0.435 take away X, so I've just removed the X squareds. 2.017 is the square root of 4.07, and then I've multiplied by this value of taking it from the bottom on one side to the top on the other. 0.435 take away X equals X, and multiply 2.017 by 0.435, and it ends up as 0.878. Take away, you've got to do times by X as well, 2.017X equals X. Take X from one side to the other, it's minus on this side, it'll be a plus on the other, 0.878 equals 3.017X. Divide by 3.017, it'll give you X, 0.0291 moles. I now know how much of this I have made in the mixture. So I can work out what's my acid. Where's my acid? Because it's saying work out the amount of acid that's in the mixture. Well, the ethanoic acid left at the end, 0.0435, take away 0.0291. I've got 0.0144 moles of acid left at the end. I also added some sulfuric acid, 0.0005 moles. But remember, 1 mole of sulfuric acid makes 2 moles of H+. It's a diprotic acid. So number of moles of H+ made equals 0.001. 0.0005 times 2 is 0.001. Now, so I've got that amount of sulfuric acid, 0.001, and I've got 0.0291 moles, 0.0144 moles of ethanoic acid. If I add the two together, I will find out that I've got 0.0154 moles of acid altogether from the sulfuric acid and from the ethanoic acid at equilibrium. Now that I've got a number of moles of acid, the number of moles of sodium hydroxide to react with the acid is the same. 1 mole of sodium hydroxide will react with 1 mole of acid. So concentration equals moles divided by volume. Concentration is 0.4, that's from the question. 0.154 is the number of moles of sodium hydroxide divided by the volume. Rearrange to get the volume. The volume is 0.00154 divided by 0.4. It equals 0.00385 decimeter cubed. Now it says it wants in centimeter cubed, so to turn decimeter cubed, a larger unit value, into centimeter cubed, I multiply by 1000, so it turns out to be 38.5 centimeter cubed of sodium hydroxide that I need.